Okay, so let's finish off number 8. So that was the square root of 7 over 175. And because that was a fraction under the radical, I looked to see if it could be simplified, and 7 goes into itself once and into 175 25 times. So now I'm doing the square root of 1/25, or the square root of 1 over the square root of 25. When I do that, 1 is a perfect square, and so is 25, so I get 1/5. Okay. So now we're going on to the next part of Unit 11, and we're going to be simplifying radicals. And we're also going to find square roots of variable expressions and use them to solve equations and problems. It says you can use the product property of square roots to simplify radicals when the radicand has a factor that is a square of an integer other than 1. And we have some practice here. The practice are the square root of 216. Okay, so if I look at that, I know that 216 is not a perfect square. So again, I'm trying to look for factors that might be perfect square factors. So I'm going to continue doing what I did in the last section, and that is trying to find some factors that might be square root factors. So it ends in a 1 and a 6, so I know it's divisible by 4, and that's good. 4 is a perfect square factor. 4 times what? 4 times 54. So now I go to 54, and I know that one of the factors of 54 is 9. And 9 times 6. So I can rewrite 216 as 4 times 9 times 6. And when I do that, the square root of 4, that's a perfect square, that becomes 2. So I'm eliminating it. Square root of 9 becomes 3. So I have 2 times 3. But what is not a perfect square and does not have any other perfect square factors is 6. So it's staying under the radical. So I can then simplify this by doing 2 times 3 is 6 times the square root of 6. And I'm done. Okay, if you notice in number 2, we have a 3 outside of our radical, which is fine. So we have 3 times the square root of 125. 125 is not a perfect square, but I know that it has a perfect square factor of 25 times 5. So I can rewrite this as 3 times the square root of 25 times 5. 25 is a perfect square, it's 5, so now I have 3 times 5 times the square root of 5, because the square root of 5 does not have any other perfect square factors. I multiply the 3 and 5 and get 15, so I get 15 square root of 5. Number 3, 2 times the square root of 112. 112 is not a perfect square. It ends in in 1 and a 2. The last 2 digits are 12, so I know it's divisible by 4. 4 times what? 4 times 28. 28 I know also has a factor of 4, and it's a perfect square. Again, you might have chosen different factors like 16 times 7 instead of 4 times 28 and then broke that down again. It doesn't mean that the way I'm doing it is the only way you can do it, but you are trying to use some of your perfect square factors to help it to make it easier when you simplify. So how do I rewrite this? I rewrite this as 2 times the square root of 4 times 4 times 7. 4 is a perfect square, it's 2. Bring that out. Remember, I already had a 2 out there. 4 is a perfect square, it's 2. I bring that out. 7 is not a perfect square, nor does it have any perfect square factors. Okay, so now everything on the outside I multiply. 2 times 2 is 4. 4 times 2 is 8. I get 8 square root of 7. All right, number 4, 891. Okay, so let's see, 891. Don't believe that's a perfect square. If I add the digits, 9 plus 1 is 10 plus 8. So I know it's divisible by 9, and 9 is a perfect square. 9 times what? Well, it's actually 9 times 99. 99 can also be broken down into 9 times 11. Again, you might have found some different factors that were perfect squares to use, but these were the ones I'm using. So I go 9 times 9 times 11. 9's a perfect square, it's 3. 9's a perfect square, it's 3. 11 is not, nor does it have any perfect square factors, so that's staying under the radical, and I get 9 square root of 11. Okay, these were the factors we ended up with. I'm just going to circle these because I didn't to begin with. All right, I'm going to put some here for you to try, and then I'm going to put the answers there, and then if you struggle getting any of these answers, just reach out to me. So number 1, the square root of 27, your answer should be 3 square root of 3. Number 2, the square root of 45, your answer should be 3 square root of 5. Number 3, 7 times the square root of 28. Your answer should be 14 square root of 7. Number 4, square root of 147. Your answer should be 7 square root of 3. Okay, so try all those and then feel free to reach back out to me if you have any questions on those. Okay, so let's go to the next part. It says, is it always true that the square root of x squared equals x? Recall that the symbol, the radical symbol, names the principal or positive square root of a positive number. Thus, when x equals -9, you would have the square root of -9 squared, which equals the square root of 81, which equals 9. Therefore, it is not always true that the square root of x squared equals x. If x is positive, the square root of x squared equals x, but if x is negative, then the square root of x squared equals -x. In either case, it is true that the square root of x squared equals the absolute value of x. So in bold, I put here, when you are finding square roots of variable expressions, you must be careful to use absolute value signs when needed to ensure that your answer is positive. Okay, we're going to discuss that when needed as we do these, so you know when you will need to use absolute value, the absolute value symbol around the variable. Because now we're going to look at expressions. So for example, number 1, the square root of 144 x squared. Okay, so when you take the square root of a variable, it's like cutting it in half. So for example, I'm going to do some on the side here. The square root, and we're going to talk about whether it's absolute value in a little bit, okay? We're just going to look at what it means to take the square root of something that's even. So for example, if I have this square root of x squared, you take half of 2 and it becomes x. Again, we'll talk about in a minute whether it's going to be absolute value or not. If you have the square root of x to the 4th, it's going to cut it in half. Half of 4 is 2. It's going to be x squared, and so on. The square root of x to the 6th is going to be x cubed, okay? So hopefully that makes sense to you. All right. If we're talking about an odd exponent on your variable, such as if I have the square root of x to the 3rd, we're going to write that as the square root of x squared times x. Why? So that we can pull out a perfect square. And the square root of x squared is x. And then you would still have the radical, and you would have the square root of x. You would still have one x that remains inside the radical. Okay, so now let's talk about this. We're going to look at this. The square root of 144 x squared, that's a perfect square. It becomes 12. The square root of x squared, we just talked about, if we had the square root of x squared, take half of it, it's x. When you take the square root of whatever it is and you now have an exponent on here that's odd, you are putting absolute value symbols around it. In this case, there's nothing there. That means it is x to the 1st power. So anything such as after you do your take the square root of something, if you have x to the first power, the third power, the fifth power, any odd power has absolute values around it because it could create a negative number if you don't have the absolute value. If you take the square root and it's an even power, it doesn't need absolute value because remember, when you square a negative or when you do it to the fourth or whatever power that's even, it's going to make it a positive number. Okay. So let's look at some more. 2. The square root of 25 n to the 8th. 25 is a perfect square, it's 5. N to the 8th is a perfect square because I can cut it in half. It becomes n to the 4th. That is an even exponent. I do not need to have absolute value symbols around it. Number 3. Okay, this is going to get a little bit trickier. 12a cubed. Okay, so I have to work at this. So first of all, 12 is not a perfect square, but I know that 4 times 3 is 12 and 4 is a perfect square. I know that a cubed is not a perfect square, but I can do a squared times a. That still has a cubed. It's just written differently. So let's go ahead and take our perfect squares out now. The square root of 4 equals 2. The square root of a squared, half of that is a. 3 is not a perfect square. It's staying inside. The square root of a, just a to the first, is not a perfect square. It's staying inside. Now, that a that we pulled out is odd. So what do we have to do? It has to become absolute value. So that's 2 times the absolute value of a times the square root of 3a. All right. Number 4. 162 y to the 10th. Okay, 162 is not a perfect square, but I know that 81 times 2 is 162, and 81 is a perfect square. Y to the 10th is a perfect square because I can take half of 10. So I'm going to do my perfect squares first. The square root of 81 is 9. The square root of y to the 10th is y to the 5th. That is odd. It's getting absolute value. What is not a perfect square stays inside, and that is the square root of 2. Okay. Let's go on to another one. Number 5. Positive or negative square root of 100 m to the 6th over 121. All of that is under the radical. Let me make that a little bit better. All right, I'm going to break this up. So I'm going to have positive or negative 100 m to the 6th. Those are both perfect squares, and so is the square root of 121. The square root of 100 is 10. The square root of m to the 6th is m to the 3rd. It is now odd, so it gets absolute values. Okay. Then the square root of 121 is 11. So that's your answer. And really the positive or negative can go in the middle, on the top, bottom. It doesn't really matter, just as long as you have it. Number 6. Okay, this is a good one. The square root of 45 m cubed n squared over 5 m n to the 4th. Okay, this is all under the radical again. So in this one, the easiest thing to do is go ahead and simplify it. So this becomes 45 divided by 5. That's 9. 9 stays on top. Do I have more m's in the numerator or denominator? I have more in the numerator. How many? 2. Do I have more n's in the numerator or denominator? Denominator. How many? 2. Okay, now it's still under the radical. I haven't taken the square root yet, but I'm about to now. 9 is a perfect square, it becomes 3. M squared is a perfect square, it becomes m, which is odd, so it is in absolute value symbols. N squared is a perfect square, and it becomes n. Okay, Unfortunately, we're running out of time and we haven't quite finished. So I'm going to stop our lesson here and then we'll pick up. It'll probably be maybe 5 minutes more and we'll be done with this. All right. See you in a little bit.